Hi everyone, myself Hariharan, Assistant Professor, Department of Civil Engineering and Commerce College of Engineering and Technology. Today I am going to present the topic slope stability. Okay, this is an important topic in geotechnical engineering. If you are going to design any slope, we have to analyze the slope. Okay, whether the slope, the existing slope will be stable, or if you are going to design a new slope, earthen slopes, whether it will resist the force coming on that slope, it will able to resist that load. It may be a water load, or it may be a natural load or man-made load, any loads, whether it will be able to resist. Therefore, we have to make an analysis before going to design any slope. Now, we are going to briefly discuss on the introduction about what is slope stability, and we are going to discuss on what are the methods of analyzing the slope stability. Now, this is a slope definition. Simply, a slope is a surface which one end on the ground and other end is on the air. It is an inclined surface which is the one end is on the higher level and other end is on the rising or falling surface. Okay, that is, a slope can be simply defined as an inclined body between the ground and the air. Okay, this is simply called as a slope. And there are the earthen slopes are broadly classified into two types. One is a natural slope. The natural slope is the slope existing naturally in the hilly areas. Okay, that is all called as a natural slope. And next one is a man-made slope. Man-made slope is the slope which is constructed or designed by the humans, and that is the slope especially on the cutting edge of the embankments and in the dam construction, in the earthen dam, and also in the highways where there is a cutting edge provider for the catchment area and for the drainage purposes. That are all the man-made slopes. And in general, the slope, whether it is a natural or artificial slope, the slopes are broadly classified into two categories: infinite slope and finite slope. Okay, what is the infinite slope? The term infinite slope will be used to designate a infinite slope which have a infinite extent. For example, in a hilly areas where it is a height of the slope will be in thousands of meters, that are all categorized as a infinite slope. And the finite slope, where the slope is of a limited extent, where you have a known depth of minimum depth of 1 meter, 2 meter, that are all considered as a finite slope. You have a finite extent. Okay, and next is the causes for the failure of slope. Why the slopes are failed? The earthen slopes are failed because of the following reasons. First, generally due to the gravitational force. The slope may fail due to the natural gravitational force also. When the load carrying capacity of the slope will exceed, it will be failed. And force due to seepage of water. The seepage of water is causes due to the when earthen slope is adjacent to any catchment area or water prone areas, the water will penetrate inside the slope. Okay, the seepage into the slope. This will affect the bonding between the earthen material and will make the slope to failure. And due to the natural erosions, okay, the erosions of the slope causing by the flowing water. Okay, it may be due to the rainwater will be continuously falling on that slope. It will causes the erosion on the surface of the slope. And due to the sudden lowering of the water in the adjacent area, when earthen while we considering earthen dam, the water adjacent to the earthen dam, when the water level is suddenly decreasing from the higher level to a lower level, this will causes the failure of the slope. And the forces due to earthquake and the natural calamities like earthquakes, there is a sudden forces acting on the earthen slope that will causes the damaging of the slopes. Okay, these are all the general reasons for the causes of slopes. And these are all the some of the patterns of slope failure. We will discuss on these are all the causes for the failure of the slope, and this is the patterns of slope will fail due to the several reasons that we have discussed in previous slide. First, this is the natural rotational landslides, and the slope failures are majorly categorized as a landslide. The landslide is the important slope failure, and this is the pattern: rotational landslide, this is a translational landslide, and this is a block slides. The earthen materials are shear like a blocks. Okay, and this is a rock fall, and this is a toppling. Toppling is the some surfaces will get cut off. shear off. And this is a debris flows is on the hilly areas. The debris, the green plants and trees are all get eroded. Okay, and this is a debris avalanche. Okay, avalanche is the completely excavated or outward movements created on the slopes. And this is the earth flow. And finally is the creep. Creep is a long term failure of the slope. These are all the different patterns of the slope failure. And now we are going to discuss the what is the necessity aims of the stability of slope. In previously we have discussed what is slope and what is the causes for the failure of slope. Now we have to discuss on what is the slope stability and what is the aim of the slope stability. Okay, the slope stability is mainly used to analyze the stability of the slope. Okay, whether the slope under the short term and long term forces. The short term forces including the force created during the construction purpose, construction practice, and long term forces will be due to the natural calamities or any creep load which is acting on the slopes, that will cause us the long term effect. Okay, and to assess the possibility of landslide. Okay, whether any possibility of landslide will be occur on that slope will be analyzed, will be identified by making the slope analysis. Whether it may be in future, whether any landslide will occur on that slope will get analyzed. And to analyze the landslide, understand the failure mechanism. Whether if the landslide will occur, we can understand the failure mechanism. Why this landslide is happened and what are the preventive measures we have to take to prevent this type of landslides in futures. That are all we can analyze by using the slope stability analysis. And to enable the redesign of the finite slope and to planning of the design of the preventive measure. If the failure, we can design the existing slope to arrest the failure loads, and if the failure is happened, we can make a if the failed slope, we can make a planning and designing to make a preventive and remedial measures without the failure will happen on the slopes. And to study the effect of the seismic load on the slope and embankments, to study the how much the earthquake force is acting, that we can analyze by using the slope stability analysis. And these are all the what causes the slope to fail. The failure of the slope is mainly caused due to the in terms of plane or curved manner. Okay, the failure will cause us in a plane manner or in a curved manner, and in other words we can say that it is a downward or outward movement of the existing of the soil mass with reference to the existing impermeable soil mass. Okay. Also, the failure occurs when the slope causes the force causes the failure will be greater than the shearing resistance, shear strength of the soil. That is, the soil will naturally have a shear strength capacity that will resist the failure of the slope to some extent. If the existing the external load acting on that slope will increase that shear strength, existing shear strength of the soil, the slope will get failure. And these are all the two important factors we have to be considered which leads to the slope failure. That is, the factor which causes the increase in shear stress due to the external load is increasing, that will increase the shear stress of the soil, and that due to the increase in shear stress, the existing shear strength of the soil will get decreasing. This causes the slope to fail. And this is a slope stability analysis. The important parameter which have to be determined while making the slope stability analysis is the factor of safety. That is, the factor of safety is nothing but the ratio of resisting force to the driving force. The resisting force is the force which resists the slope without the failure. Okay, and the driving force is the external force which is acting on that slope will makes the slope to fail. Okay, and theoretically this factor of safety value will be greater than 1. If the value is greater than 1, the slope will not fail, and if the value is less than 1, the slope will fail. And the designers should focus on the maximum factor of safety. And these are all the types of factor of safety, that is, the factor of safety with respect to the shear strength, factor of safety with respect to cohesion, and factor of safety with respect to the friction. And this is factor of safety with respect to shear strength is the ratio between the available shear strength to the mobilized shear strength. That is, some existing shear strength will available on that soil which resists the shear failure of the soil due to shear, and when the external force acting will be more than that available shear strength, that is the tau by tau m, that is the available shear strength to the mobilized shear strength. And similarly with respect to cohesion is the available cohesion to the mobilized cohesion, and with respect to friction is the available friction to the mobilized friction, phi by phi m. And these are all the types of failure will occur on the slope, that is the slope failure will occurs on the high strength soil, and the toe failure will occurs on the homogeneous soil, and the base failure will occurs on the softer soil. Okay, these are all the different patterns of failure will occur based on the strength of soil. And these are all the assumptions we have to make before doing a slope stability analysis. The first one is the stress system will be acting in two directions only, and the stress in the third dimension will be considered as a 0, and we have to use Coulomb's law while calculating the shear strength, that is S is equal to C plus sigma into tan phi, where S is the shear strength and C is the cohesion, where sigma is the normal stress acting on the soil and phi is the angle of internal friction. We have to calculate all these three parameters, and it is also assumed that the seepage condition and water level are the known parameters, and pore water pressure alone we have to calculate. And finally, the shear strength at all the points are enough to mobilize all the available shear strength, and these are all the assumptions we have to make before doing a slope stability analysis. And the slope stability analysis for now we are going to discuss the slope stability analysis for the finite slope. Okay, we have three different methods. In that we are going to discuss the only wedge failure method. Okay, in this the wedge failure method, in this a wedge failure occurs when a soil deposited has a specific plane of weakness. This is the plane of weakness. Okay, this plane of weakness will occur when one permeable soil is present over one impermeable layer. On this type of slope, when the external force acting is exceeding the available force, the slope will failure along this plane. Okay, and that is the there is a tendency of the upper soil mass to slide downward along the contact surface AB. This is called as a wedge failure, and this while doing the analysis on the wedge failure method, we have to calculate this force of mobilized force. The mobilized force is the force trying to cause the sliding of the sliding tangential components of weight W along the plane of contact. That is, this force W will causes this soil mass to slide. Okay, this is the mobilized force, and the resisting force, and that force is given as T equal to W into sin alpha. Okay, but the T is the force causing the along the downward direction will causes a slope failure, and W is that weight of that soil mass, and alpha is the angle with respect to the horizontal. And the force of tendency, okay, when the force will causes the sliding of the soil mass is the mobilized force, and the force which resists that sliding will causes the resisting force, and that is will be due to the cohesion and friction of the soil mass. That resisting force is given as S equal to C into L plus W into cos alpha into tan phi, where S is the shear strength of the soil, where C is the cohesion, and L is the length of that AB of the plane failure plane, and W is the weight of the soil mass above the impermeable layer, and alpha is the angle with respect to horizontal, and phi is the angle of internal friction, and this is the resisting force. Now you have to calculate the factor of safety. The factor of safety is nothing but the resisting force by driving force. Okay, while we are calculating these two parameters, this is the driving force and this is the resisting force. That is the ratio. Factor of safety is the ratio of resisting force by driving force, that is C into L plus W into cos alpha and tan alpha divided by W into sin alpha. By calculating all this parameter, we can identify the factor of safety, and this factor of safety will be more than 1 to make the slope without any failure. Okay. Now today we have discussed on what is slope stability analysis. In this we have discussed on what is slope, what are the different types of slope, and what causes the slope to failure, and what is slope stability analysis. And in this we have discussed one method, wedge failure method, to make a slope failure analysis. Thank you.